I just finished recording. Okay, guys, I'm also a musician. I'm also a musician. So yes, let's go. Okay, we're going to be busy with grade 11 and 12 trigonometry, like the introduction. For reduction, we are going to do the introduction for reduction. So okay, let's start with our Cartesian plane. Here's our Cartesian plane. It start from 0. It is going anti-clockwise, ne? It is going anti-clockwise from 0 here, 0 here, and then yeah, Cartesian plane. This is how we draw our Cartesian plane. This is our cast diagram. Which cast diagram, it is represented by these things. Cast diagram is just about our cos, our sign, the positivity or the negativity of these trig functions. Okay, so don't forget that in trigonometry we have sine, we have tan, we have cos. Don't forget that sine is opposite over hypotenuse, and then tan it's opposite over adjacent, ne? So then cos is adjacent, is equal to adjacent over our hypotenuse. So basically here it means like uh so here in this Cartesian planes, our triangles, I mean like our right angle triangles, they are going to be like this. I didn't draw them here because uh it was gonna limit me with like other information, so let me do it on the other side. So okay, we have our Cartesian plane, which is this one, eh? I'm trying to make an examples on how we draw like our right angle triangle so that you can understand trigonometry. I love drawings because drawings make things easier for me. That's how I do things, most especially when it comes to things that require our drawings, just as in Newton's second law and this kind of stuff. So okay, let's start now drawing our triangles on our Cartesian planes. So here's our first quadrant, and this is our second quadrant, and this is our third quadrant, and this is our fourth quadrant. So on our first quadrant, here's how we are going to draw our triangle. Our triangle will be like this, on our first quadrant. So on our second quadrant, our triangle will be like this. So on our third quadrant, our triangle will be like this, ne? On our fourth quadrant, our triangle will also be like this. So well, this is our right angled triangles. You want to so well, this is our hypotenuse, and this is our opposite, 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 and then these ones are our adjacent. So okay, um okay, let's do it like this, ne? So okay, I'm done showing you how to draw the right angled triangles on our Cartesian plane. Now this will help you like to attempt other questions as well. You can see here we have our you can see on our left side, from our origin to the left side, the numbers are always negative, ne? And then from our origin to the right hand side, our numbers are positive, ne? So then this is our x axis, ne? So this is our y axis. So numbers that are going upward, they will be positive, and the numbers that are going downward, they will be negative. You know what I mean? These are our Cartesians. This is our Cartesian plane, ne? So okay, let's come to our introduction here. This is called a cast diagram. The cast diagram, this it's like this. Cast diagram is CAST diagram. One. This is our cast diagram. This is just represent, this is our cos, this is our sine, this is our tan. So A, it just represents all, it just means all. So okay, it just speaks about the positivity and whatever one. So okay, let's go on our, this is our first quadrant. Don't forget that this is our first quadrant, eh? Our first quadrant is okay, from 0 up until here is 90 degrees. One, it's 90 degrees. That's why they say 90 degrees minus our angle. The angles that you're going to find here is like 90 minus any angle that you're going to find here. It means that on this quadrant the angles will be less than 90. That's why it is 90 minus the angle. So here this all is an A on our cast is an A, which means that all of these trigonometric ratios, our tan, our cos, and our sine, they are positive in this first diagram. They are all positive. Hence you see this thing 90 minus is it theta? Yeah, it's theta or something. It's theta or something. Yeah, this is how you draw your Cartesian your cast diagram, guys. From 0 up until 90. It's 90 minus 90. It means that any angle that you're going to find here, it has to fall under this quadrant. It has to be less than 90 degrees. So then let's go to our second quadrant. Vele, okay, we said that from 0 up until here is 90. So then from 0 on our first quadrant is from 0 up until 180. From 0 up until 180. This is our second quadrant. It's 180. So on our second quadrant it will be 180 minus the angle that you're going to find here. Let me just say theta and not x. Let me just say theta and not x, and also here is theta and not x, so that you understand this thing. Okay. Because I can see somewhere I've written about theta and then x, so then like it will confuse other students, so I don't want to do that. So okay, on our second quadrant, I've said our second quadrant is from 0 up until 180, and then remember on our first quadrant we said it's from 0 up until 90. So on our second quadrant it will go from 0 up until 180, which means that the angles that are going to fall here, you can see this thing. You can see this thing. These things, they will help you. These things, they will help you. It's 180 minus theta, which means that the angles that are going to fall here, they should be less than 180 degrees. That's why it is 180 minus the angle theta. So in here, I get it on our first quadrant, we said like all these trigonometric ratios are positive, so then on our second quadrant only sine is positives and then the rest are negatives. Our tan, our cos, they are negatives on our second quadrant. So okay, we'll deal with the questions later on. We'll deal with the questions later on. I just want you guys to see this thing, but like, okay, we can still do. Okay, yeah, no, we'll come to the examples. Let me first explain these things, and then we'll go to the example. By doing the examples, you'll get there. You'll understand these things. These things are simple. You'll understand them. So okay, let's go to our third quadrant. Third quadrant is from 0 up until this side 270. You can see it's from 0. Just know when you draw a Cartesian plane from 0, 90, 180, 270, and then 360. 360. This is revolution. 360, because you are going from the origin and then going back to the origin. This is revolution. So I've said that on our second quadrant only sine is positive and then the rest are negatives. So okay, let's come to our second quadrant. Our second quadrant is 180 plus theta. You can see now we are past 180. We are past 180. We are now below 180. Like we are past 180. Like we are no longer less than 180 or 180 or something. Like we are bigger than 180 now. On our third quadrant, we are bigger than 180. Hence 180 plus theta, which means that the angles that you're going to find here, they have to be bigger than what? Than 180 now, because of a plus. Because now we're past 180 degrees. The angles that we're going to find here, they have to be bigger than 180 on our third quadrant. So on our third quadrant, we have tan. Don't forget cast diagram. Cram this thing. Cast diagram. It's CAST. So now we are on tan. We are at T. We are at T now. We are at T now. So we are at T on our third quadrant. Only tan is positive, and then the rest are negatives. Sine and cos are negative on our third quadrant. One. So then let's come to our fourth quadrant. Yeah, okay. Let me explain further. I've explained this 180 degrees plus plus theta plus theta. So guys, this is just basically you add 90, 90, 90, 90 on. That's all that. So then here, in order to find 270 value, I think they've added 90 on 180 degrees. They've added 90 on 180 degrees. So they found 270 degrees or one. So okay, on our third quadrant, I said tan is positive and then the rest are negatives. So we also have, like, you can 270 minus theta. Or what? We're still on our third quadrant. Is 270 degrees minus theta, which means that the angles that you're going to find here, when you use this instead of this, when you use this instead of this, it means here you're saying 270 minus the theta, which means that the angles that you're going to find here, they have to be less than what? 270, but greater than what? 180. You feel me? So okay, let's go to our quadrant 4. Quadrant 4, that's where our revolutions start to complete. One. So we have cos on our fourth quadrant. One. So on our fourth quadrant, because we know that this falls under revolution, which is 360, it means that the angles that we're going to find here, they have to be less than 360 but greater than 270. You can see, because we're past 270 now, we're heading where? To 360. So you have to add the angle so that they give us numbers that are greater than 270. But when you use this one, 360 minus theta, it means that the angles that are going to be here, they have to be greater than what? They have to be greater than 270 but less than 360. But when you use 270 plus theta, because it's plus, because we are past 270 or moving towards 360, so it's a plus now. It's only minus when you are below that angle. One. So now we're passing 270 going to 360, so we have to add an angle. Yeah, let's go. So here on our fourth quadrant, only cos is positive. It is only cos that is positive, and then the rest are negatives. Remember that all on our first quadrant they are all positive, but on our second quadrant only sine is positive. Then on our third quadrant only tan is positive. Then on our fourth and final quadrant only cos is positive, and then the rest they are negative. Now, so okay, let's go further. Procedure of reduction. Examples of one. So okay, we're here now. These are just examples, ne? So we have sine into bracket 180 degrees minus x. Should I just say, okay, let's just say, yeah, x and theta, these are the angles, same thing, guys. Yeah, and I just love x, I think. I think I just love my x. So okay, let's go. Sine 180 minus x, ne? So here you're going to look at your angle is 180 minus, and it's, you can see it's sine, eh? It's sine 180 minus x. So then you're going back to your cast diagram. You're going to look for that 180 degrees minus x. That's why I'm saying that you need to understand, you need to know all these things by your head, so that when you come to your exam, you don't find like you don't come across like about the difficulties like that to remember certain things and stuff like that, or one by the head. So when you have your drawings in place, then you're good to go. So okay, let's go. It's 180. Let's go look for 180 minus minus x, or maybe theta on our diagram. I don't know. Maybe let me write theta once so that I don't confuse people. I don't want to confuse people. I don't like confusing people. I'm a confusion myself. So okay, let's go. It's sine 180 minus theta, ne? So okay. So it means I'll have to change everything. Okay, theta, 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 theta. No x's now. It's only thetas. So okay, look for your 180 minus theta on your cast diagram. So we are here now. It's 180 degrees minus theta. And remember that here on our second quadrant, only sine is positive. And we do have sine here, ne? We do have sine. So it means but actually you find the 180 degrees minus theta, ne? So it is equal to sine theta. You only take this variable only and leave out the 180 degrees. Then your answer will be positive sine theta, because sine is on our second quadrant and it is positive. It's like these 180 degrees minus theta. It's our direction. It is just showing you, good, hey, look at this quadrant. Look at this quadrant and find if whether your trigonometric ratio is positive or negative now. So then we'll find sine on our second quadrant as what? As positive. So then it's going to be sine theta. So then let's go to our second example, which is cos 360 minus theta, which gives us cos theta. I get it? It's cos now, ne? And you have 360 minus theta. Just go and look for your 360 minus theta on your cast diagram. On our cast diagram, 360 minus theta is on our fourth quadrant. Here it is, guys. Here it is. So then it's cos, ne? It's on our fourth quadrant, and on our fourth quadrant only cos is positive. Then the rest, they are what? They are negatives, ne? They are negatives. So okay, let's go. It's cos theta, and it's a positive trigonometric ratio because it follows the principle of cos being a positive on our fourth quadrant, or one. So then let's go to our third question, which is tan 180 minus theta, which gave me negative tan theta. One. So it's like this. Tan. Okay, look at your 180 degrees minus theta. It is just giving you a direction on which, like, it gives you it indicates like a quadrant in which you need to find your tan as whether positive or negative. It's you get me. So then let's go. 180 degrees minus theta is on our what? On our second quadrant. Go to your second quadrant. 180 minus theta, your second quadrant. But what do we have here? It's a tan. It's no longer a sine. It's tan. One. So then don't forget. Okay, now we are on our second quadrant. On our second quadrant, we have sine, which means only sine is positive, and then our tan, our cos, they are negative. Hence, I found negative tan theta. Here you only write the variables. You no longer write double 180 degrees now. One, you just add the if whether it is positive or negative now. So now we'll find that our tan on our second quadrant is negative. That's why I wrote negative tan theta there. So then let's go to our fourth example, which is sine 180 degrees plus theta. So okay, let's go look for our 180 degrees plus theta on our cast diagram. Where is this guy? Okay, here's our guy. Here's our friend, 180 plus theta. So okay, we have sine 180 plus theta, which is equal to negative sine theta. It gave us a negative answer, and you will know why. So let's go look for our 180 degrees plus theta. Okay, it's on our third quadrant, So on our third quadrant, we have tan. We have tan, and only tan here is positive, which means sine and cos, they will be negative. So it's sine 180 plus So it is equal to, it gave me negative sine theta. One, because sine on our third quadrant is negative. That's why I wrote negative sine theta. So let's go to our is it our second last question example, which is cos 180 degrees minus theta, which gave me negative cos theta. So here's why. 180 degrees minus theta. 180 degrees minus theta is on our what? On our second quadrant. Why it is on our second quadrant. 180 degrees minus theta. It is on our second quadrant. So as it is on our second quadrant, and we know on our second quadrant only sine is positive, so then the rest they are what? Negative. So we'll write cos as negative. It will be negative cos theta. So then let's go to our last question, last example. Tan 180 degrees plus theta is equal to tan theta. So it's tan 180 plus theta. Let's go look for our 180 degrees plus theta on our diagram. It's on our what? We have 90 minus theta here, we have 180 minus theta here, so then on our third quadrant we have 180 plus theta. One, we were not given these ones. We were given these ones. One, we were not given these ones. So we are given these ones. That is why we're looking for these ones. One. So it's tan 180 plus theta. So okay, we're on our third quadrant now because we have 180 plus theta. We have a plus there. So, and remember, we have tan on our third quadrant, which is positive. It means that only tan here is positive, and then sine and theta, they will be negative. So we have tan theta as our answer. Yes. We're good to go. We're good to go. We're good to go. So then let's go here. Reductions that involve 90 degrees. So these ones, they change, they enter a whatever that is, but they change. Once are, yeah, it's like they change, they become like some friend, they become friend like that or one, they become friends like that or one. Reductions that involve 90 degrees. So we have sine 90 degrees minus theta. So you know that these ones, this one falls under our, it's our first quadrant, and this one also, but this one is our second quadrant because it's a plus angle, which means it will be greater than 90 now, but less than 180. Let me just say it's greater than 90 or one. So and then we also have, okay, 90 plus x. Okay, yeah, it's the same thing. So okay, sine, but these ones, they'll change. Hence I've said, like, they become like friends. They become like friends now or one. So we have sine 90 degrees minus x. So it's equal to cos x. I said it's changed now. They change. They become, this one is now a friend of this one. One, it's cos and sine. But we only write the variable, not these ones. We don't write our 90 degrees and our negative what. We only write the variable, the positive variable. So this one will change from sine to cos. This is just the way it is. You have to know this. This is just the way it is. So we have cos 90 degrees minus x is equal to positive sine x. It's positive because it falls under which quadrant? The first quadrant. 90 degrees minus x minus theta minus delta minus whatever angle that is. It will be positive on our first quadrant, but it changes this identity. One, it's no longer cos, it's now sine. That's why I've said they become now friends. So we have sine 90 degrees plus theta. So 90 degrees plus theta, this one is on our, let's start look at our first quadrant, and then okay, we don't have this one on our first quadrant, but on our second quadrant we have 90 degrees plus theta. Now or now 90 degrees plus theta. One. So the identity is only the identity that changes, but then the rest don't change. But we just take out our 90 degrees and our plus sign, and we just take them out. Like we take these ones out, and then we're left with the positive variable. So it means sine 90 plus x is on our second quadrant. So, and sine is positive on our second quadrant, which means that the friend of sine will be positive and not negative, which is cos. Now is positive. It's positive, positive. So then let's go to cos. Cos 90 plus x. So, okay, now it's a cos. And on our second quadrant, we only have sine as a positive identity. So, okay, it will change value, this one from cos to sine, but then the signs, that's what we are going to look for. That's where the problem lies. You know what I mean? So only sine on our second quadrant is positive, which means the cos will be negative. So hence I have the negative answer, which is negative sine x. Is a negative, but this one they change. Again, they become friends now from cos to sine. One. So okay, yeah, we're done here. Let's go to the the examples, guys. Here the examples, guys. Here the examples. Yeah, you can just pause the video and then do them yourselves without looking, so that you understand what you're doing. So okay, they say what to do when it is not on the cast diagram. What to do when it is not on the cast diagram. You can see our first question, our first example, is not on our cast diagram because it's x minus 180 and not 180 degrees minus x. And you even if you swipe, you can't swipe them. Even when you swipe, it'll still be invalid. It'll be sine into 180 and then plus x. We still don't have these on our cast diagram. So okay, here's what we do. We have sine x minus 180 degrees, which is equal to, it will be sine, and then what do? You say x minus 180 degrees, and then you add 360. This is what you do when you don't find these identities on our cast diagram. This is what you do. You add 360 on the angle, so it will give you a positive angle, so then you can swap them. So then you can swap them. So we have sine inside x minus 180 degrees plus 360 degrees, close bracket. So it's sine. You can see these things, guys. You can see sine into bracket x. So then now we have a positive a positive angle. So now we can like swipe them and then it will give us a positive. Guys, look at this thing, man. It's so beautiful. It's sine 180 plus x. So then I get it. Now you've gone further with your calculations, ne? So then let's do this. Go and look for this angle, at your on your cast diagram. 180 degrees plus x is on our third. It's on our third quadrant. You see this thing? It's on our third quadrant. So it means on our third quadrant only tan is positive, and then the rest they are negative. Sine and cos, they are negative. So okay, I was lost a bit. So 180 plus x is on our third quadrant. So on our third quadrant, it is only tan that is positive, which means your sine will be negative. That's why I've got negative sine x. Now one. Okay, can we? Okay, let's go further. Okay, yeah. This one is different. And then we have sine 540 degrees minus x is equal to sine into 540 minus x, and then you minus by what? By 360. Here it is either you add or subtract. But when you have like a bigger value, a value that is greater than 360, that's when you like subtract. You subtract, ne? Yeah, you minus or one. You just minus 360. But when you have a number which is less than 360, you just just say plus 360. You just add 360 or one. You just add 360, and then it will give you a good one, a good value. So here we have a greater number which is 540, so you have to minus by 360 so that it gives you a number less than 360. That's what you do. So now we have sine into 540 minus 360, it gave us 180 degrees, and then minus x. You can't minus x and 360 because this one is a variable, it's unknown. These are not the like terms, you know what I mean. The like terms is 540 and 360. So okay, you have sine into 180 degrees minus x. So go into your cast diagram and look for 180 minus x, and then that's when we'll determine the sign of our, I mean like a positive sign or negative sign of our sign. Yes, it's signs. We're talking about signs. Okay, I've said 180. We're going to look for 180 minus x. It's on our second quadrant. It's on our second quadrant. This is 180 minus x. And then don't forget, only sign here is positive, and then tan and cos, they are negative. So okay, here we are. Okay, we're on our second quadrant. So value, you know, sign is positive. We have our positive sign here. So then okay, let's come to these ones. So we have cos into negative x is equal to, we don't have our plus 90 plus what, but this is not in our cast diagram, so it's either we add 360 or minus 360. But here we have numbers which are less than 360, so it means like we'll have to add because it's zero. The constant number is zero here, or one. It's zero. It's minus x, like automatically it's plus zero, but you don't have to write zero. So it means like we'll add 360 on our identity, which means it will give us so it will give us cos into minus x plus 360 degrees. So it's cos into 360. You see, they swap these ones are swipeable. You can swipe them, are swipeable. You can swap them. Wabon, you can take 360 because 360 is already a positive. Like you need to have a positive angle here. Wabon, you need to always have a positive angle here so that you can swipe them. But if you don't have a positive angle and it's negative, it's either you add 360 or minus 360. So here we go. So okay, we have 360 minus x. So go and look for 360 degrees minus x on your cast diagram so that you can find your final answer. So okay, 360 minus x, I know that is it. This one is on our fourth quadrant. And on our fourth quadrant, cos is positive. That's why I have a positive answer here, which is cos x. So okay, let's go to our second one. So we have sine into negative x, which is equal to sine into negative x, then you add 360, guys. You see, so then it's sine into 360 minus x, so then it will give you a negative sine x, because find your quadrant using this angle 360 degrees minus x. This is our fourth quadrant, guys. So on our fourth quadrant, only cos is positive, and then tan and sine, they'll be negative. So we will have a negative sine x. So okay, let's go to this one. So you have tan into negative x minus 180 is equal to tan into negative x minus 180. We said we either add or subtract. So 180 is less than 360, so you can add 360 or 1. So you have tan into negative x plus 180, because it's minus 180 plus 360, you will have a positive number, 180 degrees. You always take the sign of a bigger number. So it's turned into 180. These ones are swipeable. You can swipe them because we have a positive angle now. You can swipe them. You can take this one and put them there and put this one there. So it's 180 minus x. So look for your quadrant using this one so that you can determine the signs of our identities. 180 degrees minus x is on our second quadrant. So on our second quadrant, it is only sine that is positive. So which means tan and cos, they will be negative. That's why I got a negative tan x answer. So okay, let's go. Let's carry on. I'm doing this more so that you guys can understand these things. I want you guys to grab these things. I don't want you to forget these things. I want you like to master them so that you don't fail trigonometry. So sine 720 minus x into sine into 720 minus x minus, okay, this one is greater than 360, so then you have to subtract, you have to minus by 360. You can't add 360, you have to minus. It is greater than 360. So okay, let's go. It's equals to sine into 720 minus x minus 360. You subtract, so then we have sine into 360 minus x. So then you look for your quadrant using this angle. 360 minus x is on our fourth quadrant, and on our fourth quadrant only cos is positive. It is only cos that is positive, and then sine and tan, they will be negative. That's why I got a negative sine x. So let's go further. Sine x minus 90 degrees is equal to sine into all right. We're here now. Okay, here's what you do. You'll say sine, and then what do? Here, because we already have it's 90 degrees, and then okay, this is how we do it, no? Because this one, yeah, we can find him on our quadrant, ne? We can find him on our quadrant. It is just they just misplaced the terms or one x and 90 degrees. They just misplaced them or one. So we have to like place them correctly. So here's how we do this thing. So you'll say sine into, and then you take out the negative sign. You take out the what? The negative sign, and then you say into negative x, because you are saying negative x because this x comes from the multiplication of negative 1 multiplied by negative x, and then it's positive x. So Tina, here we're just looking for want to place these things correctly. So then you take out, this thing, factorization and stuff. We did these things, factorization. You just take out the negative sign there, and then you are left with a negative x plus. It's a plus. It's no longer a negative. It's a plus, because when you take negative multiply by plus, they'll give you what? A negative answer here. So see, now we're just we're just breaking this thing down backward. We're just breaking these things down backward. So we have sine into negative, and then these ones you can swipe them now because we have a positive angle now. It's 90 degrees minus x. So and then all right. Don't forget that we did this one before, where you add like plus 360 on this one. We did this one before, when you add like a 360 on this one. Here's this. Where is it? Here is this one. Here it is. Here basically you're just doing this. it's a sine into negative angle. You take these ones as the whole angle. It's like your representative of x. Ones what? It is like a representative of x. But then and then you go and look at your quadrant on your cast diagram. This one you can find him on your quadrant, which is um it is 90 minus. Okay, it was 90 minus, so you can find him on your first quadrant. So yeah, you can find him on your first quadrant. So okay, very like yeah, we already know that sine negative, the angle is equal to negative sine x. So then you say negative sine. So then in place of this x, you are going to place 90 degrees minus x, one, so that you can find your identity, your final identity. So when we go, I get it now, we have negative sine into 90 degrees minus x. So Vele, when it's 90, you always change these friends. These are friends, they become friends now. Sine and cos, they become friends. So from sine, you're going to what? Cos. So we have a negative, our value, we have a negative. Now it's negative because of this one. You know what I mean? So our final answer is negative cos x. So okay, let's go to this one. I'm still going to do the same thing. It's okay. You can see. Now it's cos, it's no longer sine. We're still going to do the same procedure. It's cos, take out what? Negative sine, and then into negative x plus 90 degrees. You know what I mean? One. We are breaking these things down backward. I don't even know if I can say backwardly, but then murao, rechechela murao. One. So it's cos negative into negative x plus 90 degrees. And then now we have these ones on our cast diagram. We can just swipe them. One. So it's cos into negative into 90 degrees minus x, close brackets. So then let's go. We already have this identity cos into negative x, which is equal to, it is cos x. It gave us a cos x. I remember, man. I did it, man. I remember, but then okay, let's go. I did it somewhere. I remember him, man. I did him. Yeah, no. One. Cos negative x. This is how you do it. When you want to find your cos negative x, this is the procedure that you need to follow. The procedure that you need to follow, and don't forget to look at your cos diagrams when you do these things. So we have, so then our cos, like this is cos into negative this angle. Take this angle as one, as the same thing, as like they are attached, like they are one thing. Obon, yafana na dideng, yafana. But you just have to, in place of x, replace it with this angle. Obon, that's what we did here. Obon, but then this one is a positive cos because it's positive on our third quadrant, because I get it from here. You have to plus 3 sigi so on, so that you can find your cos x. So then yeah, I think we are done here. Cos into 90 x, and then you have sine x here. You have your sine x. Yeah, that's it. Okay, so now let's go to reduction using numbers and special angles. Using numbers and special angles. Don't forget your cast diagram, guys. Don't forget your cast diagram. We are saying all positive, sine is positive, tan is positive here, cos is positive here. Then the rest are negatives. Alright. So okay. Example. We have sine 200 is equal to sine into 180 plus 20 degrees. Here's what you're gonna do. Here's what you're gonna do. you find the angles that will make these 200 using your cast diagram, using those angles, our 180 minus theta or 180 plus theta, or 90 minus theta or 90 plus theta. One, that's what you do here. That's what you do here. So then, how did they find 200? In order to find 200, the 200 falls where? It falls where? 200, it is past 180. It is above 180. So it means they added an angle in order to get 200. It means this angle falls under which quadrant? It falls on our third quadrant, because it is between 180 and what? And 270. So it means we are going to use this identity, 180 degrees plus an angle. That makes the final answer, which is 200 here on our first question. So it will be sine into 180 plus 20 degrees. So then you only take the angle that you added here. You no longer take the whole thing or plus the whole thing. You just only take the angle that you added into your final answer. But then here comes the thing of the sines. So on our 180 degrees plus an angle, I get it, it's on our third quadrant. So look at your third quadrant, if whether sine is positive or negative. So on our third quadrant, only tan that is positive. Well, it means our sine will be negative. So hence we have a negative sine 20 degrees. So now we have sine 340. So you are going to look for the angles that will make up this one. You either add or minus an angle. So 340. You can see this one is near 360. Is near 360. So you just subtract. You just find an angle that will make 340 out of 360. So I get it is sine 340 now is equal to sine into 360 minus 20 degrees. Oh, it means like they subtracted 20 degrees in order to find 340 from 360. So here we'll have, you only take the angle that is added and not the whole thing. You don't add or subtract the agree, you just break down your components now name, and then you take that angle that was added or minused. So you go and look for 360 minus an angle on your quadrant, and then you'll find that 360 is on our fourth quadrant. So it means 360 minus any angle is on our fourth quadrant. It means your sine on your fourth quadrant will be negative, because only cos there is positive. You get me? So here's your final answer here. It is negative sine 20. So okay, we have tan 300 now. Yeah, you just look for the angles that make up 360. You either subtract or minus or 1. So it's tan now. It's tan 300. So 300 was made by adding or subtracting a certain angle. So when I just go and look for the easiest one, look for the easiest one, the ones that you're going to find that are going to be simple for you. For one, so we have 360. 360 is on our fourth quadrant. Yeah, don't be scared, man, to draw your cast diagrams. You see, they're very helpful. They are very helpful, guys. So 300 was made by 360 minus 60 in order to find 300. So we know we're already on our fourth quadrant. On our fourth quadrant, only cos is positive. So here tan will be negative. So it will be negative tan the angle that was minus 1. That's how we do it. So sine 150 is equal to sine into, you look for the angles that will make 150. You either minus or add 1. So it's 180 minus, because it is less than 180, this one. So it will be minus what? 30. These angles, they make up 150. We're just breaking these things down backwardly. Is it backward or backwardly or whatever? So then it's sine it. 180 minus a certain angle is found on our second quadrant. Ne? It's on our second quadrant. So you know that sine on our second quadrant is positive. That's why it is positive here. And then you take an angle that was added there. So then you have tan. We have tan. It's tan 730. So then it's equal to tan into 730. You minus. Well, you can see this one is not on our cast diagram, and this one is greater than 360, this angle. So you have to minus by 360 until the angle becomes less than 360. Until it becomes less or close to 360. So okay, let's go now. We have tan 780 minus 360. So then it's tan into, we have 370 now. It's closer to what? 360, and you can add, or you can minus a certain angle, just the mini angle, in order to find your final answer. So here, in order, okay, you can see this one. It is still greater than 360, so it is tan 370 minus 360. We're doing it for the second time. We did it the first, we're doing it the second time, because this angle, it is still greater than 360. We have to find a smaller angle. So it is tan 370 degrees minus 360. So we have tan 10. So then you are done there. So okay, let's go on our, is it our last one? No, it's not our last one. Okay, it's tan into negative 100. It's equal to tan into negative 100. You can see this one is well, it's not on our cast diagram. Yeah, we're still going to use that procedure that we used before, where you add and subtract 360. So it's minus 100 plus 360 degrees. And then now we have tan 260. It is a negative, and we have to find a positive angle now. So it is tan. So let's find the angles that make up 260, which is 180 plus 80. And this one is on our third quadrant. That's why our tan is positive. So okay, let's go. Okay, we have sine 100 here. 100 was made by sine 180 minus 80. Just minus 80 there, in order to find your 100. So then let's look. Where is our sign positive? Is it positive on this identity? Nah. On this quadrant? Nah. Yes, it is positive. This is our second quadrant. You can see the negative sign here is 180 minus negative sign. If it was plus, we're going to go to the third quadrant, and then our sign was gonna be negative. But now it is positive because it is on our second quadrant. So okay, let's go. The special triangles. So you need to also, this is just an introduction, guys. This is just an introduction. We're still going to do more. I also want to cover the grade self-learners and the grade okay, yeah, and 11 as well. But then we'll be busy with the grade 11s and 12 this week for trigonometry and vertical projectile motion. So okay, now we're busy with trig introduction. So okay, the special triangles, these ones you need to know them by your head. Yes, by your head. You need to know them by your head. These special triangles, you need to know them by your head. You need to know them by your head. These ones, don't forget them, and don't forget your cast diagram. Okay, as we're still going, I said, like, the special triangles, you need to get them, like, you need to know them by your head, like, with your head. Like, you need to know these triangles and their values, the angles, and the sides. Like, you need to know everything with these triangles. Like, you don't rob us. Like, you need to know everything with these triangles. You need to know what is your hypotenuse on these 45 angle, the triangles, And then on your 30 degrees and 60 degrees triangle, you need to know your hypotenuse, your opposite, and your adjacent. Yes. Okay, connecting. All right. So okay, we're going to go with our let's start with our examples. We have sine 300 is equal to sine 360 minus. Okay, guys, you can see these things. They are like they have a certain relationship. You know what I mean? Like they have a certain relationship. Now look. Okay, let's go look at this thing. We have sine 300 into sine. Okay, let's look for the angles that made 360. Yeah, 300, not 360. So it's 360 minus 60 degrees. Answer, because you just cancel the 60 here and you're left with 300. You know what I mean? So then you know with 360 minus an angle is on our fourth quadrant. But then look for the signs. You know on our fourth quadrant it is only cos that is positive. So it means your sine will be negative and then your tan will also be negative. And here don't forget we have a special angle which is 60. And here they won't ask you to use a calculator, bruh. They won't ask you to use a calculator here. Answer. You won't be allowed to use a calculator, and they will see in the exam, in the memos, that you've used a calculator. You know. So then, when agree you have a negative sine 60. When I just go look for your sine 60 on your don't care about the negative one. Just go and look for your sine 60 on your special triangle. Okay, here's our special triangle where we have a 60. Again, we have two special triangles. We have this one with 45 angles, so one, and our hypotenuse is square root of 2, and then your opposite is 1, and then your adjacent is 1. And then here on our 60 and 30 degree special triangle, we have our hypotenuse as 2 and our opposite to 60 as square root of 3, and then our adjacent is 1. So then let's go to our example here. You can see that your sine 60 is what? And you know that your sine is always opposite over hypotenuse. So what is your opposite here? It's 3. It's square root of 3. And then you over, what is your hypotenuse? It's 2. So so now you can go with your negative sign, and then in place of sine 60 you place these values, and then you are done. Don't use a calculator. My guy. So we have cos into negative 60 degrees is equal to cos into minus 60 degrees plus 360. You are adding, guys. You are adding now. You are adding plus 360. We did this. So then minus 60 plus 360, you are going to be left with a positive 300, because you always take the sign of a bigger number. Don't forget that. Always take the sign of a bigger number. So then we are left with cos 300. So then, okay, let's go look for the angles that made 300. We have cos 360 minus 60. One side. So then we're left with what? So this one is on our fourth quadrant. So then on our fourth quadrant, cos is positive. That's why we have a positive answer here. So then we're left with what? We have a cos 60, and then cos 60. Go look at your special triangle, and then you'll find your value. Don't use your calculator. We're looking for cos 60. Cos 60. Cos, you know that cos is adjacent over hypotenuse. Our adjacent here is 1, because it is adjacent to our hypotenuse. It is adjacent to our 60 degrees of 1. So then our hypotenuse is our 2. So it's 1 over 2. That's your answer. 1 over 2. So then we have tan into 210. It's equal to tan. We're going to look for the angles that make 210. So we have tan into 180 plus 80. Yes, because it made 230. You just add 80 to 180 and it gives you 210. Once more. So then you have tan. So then let's go look for 180 plus an angle. on our quadrants. We need to find like which quadrant does our tan lies on. So 180 plus is our third quadrant because the angles there are greater than 180. So then it's tan 180 plus 80 degrees. So then our tan on our third quadrant is positive. It's positive. So then we're left with tan 30. So then tan 30, we have a special angle here which is 30. These are special angles 45, 30, and 60. These are our special angles. So you know that when you have a 30 as your angle, just remember to look for your special triangles. So then tan 30. Let's go back to our special triangles. We have sine 30, sine 30. No, it's tan 30. Yeah, it's tan 30, tan 30, tan 30, tan 30. So it's tan 30 then you just you just turn your book, your angle, so that you can find for your hypotenuse and your adjacent and your opposite. So now we're talking about sine 30. I'm sorry, it's sine 30, and then sine 30. Here is our sine 30. So on our sine 30, square root of 3 is adjacent to our hypotenuse, and then 1 is opposite to our hypotenuse and also opposite to our angle, and this one is adjacent to our angle and our hypotenuse. So then let's find for our tan 30. You know your tan is always opposite over adjacent, so your opposite is 1, your adjacent is square root of 3. So then here's your answer. Here it is. Tan 30 is 1 over square root of 3. Opposite over adjacent. So then let's come to this one. You have cos 390 degrees. So it's cos. So you know 390 is greater than 360. So it means here you'll have to subtract. You have to minus 390 minus 360. You don't add 360 here. So then it will be, you are left with cos 30. It's a special angle. Cos 30. You know your cos is, okay, turn the book. You know your cos. Our cos is adjacent over hypotenuse. So here's our, our special angle now is 30. So we're going to look for our adjacent here, and then our hypotenuse is already there. So our answer will be square root of 3 over 2. Here it is. You can see it, guys. You can see it, né? Here it is. Here's your answer. Yes. So yes, and this thing, I was trying to get this, but then I never came across this thing, but I learned it from somebody. So sine and cos can complement each other, which means that sine 20 is equal to cos 70 because the angles add up to 90. Or what? It's like they are equal. Sine 20 is equal to cos 70 because the angles, they add up to 90 degrees. And then we have cos 10 is equal to sine 80. 80 plus 90 plus 10 is equal to 90. So then it means they are equal because their angles add up to 90 degrees. So any combination that adds up to 90, you can make them equal. Use this when simplifying. Simplifying, you can see cos 70 over sine 20. 70 plus 20 is 90. So it means that these ones, they divide one another. The answer is 1. They cancel one another. The answer is 1. The answer is 1. Like if you find the angles adding up to 90, just give them the equation sign. They are equal, and your answer will be 1 because they cancel one another if they divide. And so it will be 1. So okay, well, I think, yeah, we're done for today, guys. We're done. We're so done for these intros, but you need to know them, remember everything that we did today. Let's go. This was just an introduction. We're still going to do more questions like simplifying, and yeah, for the grades also, we're still going to do the identities, and stuff like that. Now we're busy with the reductions. So, okay, let's go.